Since 2018, we have been receiving a mysterious signal every 22 minutes, and its source remains unexplained. Some scientists even believe it might be from another civilization. Interestingly, this strange radio signal wasn't discovered by a scientist on a serious mission, but by Tyrone O'Dory, an undergrad student at Curtin University in Australia. He was sifting through old data of the southern sky for a school project and stumbled upon a signal from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough, but despite checking different frequency data, they hit a dead end. Then Natasha spotted a pattern: the signal repeated every 18 minutes. This was huge, but just as they were gearing up to study it further, the signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up when suddenly, a new signal popped up. This one kept blinking for 5 minutes, then disappeared, and then it came back exactly 22 minutes later. The main question was if that signal was related to the 18-minute one. Natasha went back to the old radio data from that area, and as they dug deeper, they realized that yes, these signals have been beaming towards Earth for 35 years. Indian and American telescopes had caught them back in 1988, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was: 15,000 light-years from Earth. However, the exact nature of this object remains unknown. The signals still pop up every 22 minutes on NASA's screens, always ending with a frustrating, "match not found" message. Scientists have various theories, including that it might come from extraterrestrial beings, pulsars, magnetars, or even dwarf pulsars, but none of these theories have been fully confirmed yet. The signal's behavior is very strange and suggests an unnatural source, indicating there might be something in the universe that scientists haven't fully explored yet. There is also another mysterious type of signal called fast radio bursts, FRBs. These are quick, intense bursts of energy in the form of radio waves that can be brighter than entire galaxies. Despite their brightness, they only last for a fraction of a second, making them difficult to understand. Scientists are still trying to figure out what causes these FRBs, which could be coming from sources like magnetars, colliding stars, or even merging galaxies. Meanwhile, Voyager 1, which has been traveling through interstellar space for more than 45 years, began sending strange signals to Earth. Voyager 1 was launched by NASA in 1977 to explore the outer planets of our solar system. Initially, its mission was expected to take about 5 years, but it has far exceeded those expectations. Voyager 1 has provided a wealth of information about Jupiter, Saturn, and beyond. It sent back stunning photos and discovered several new moons and a previously unknown system of Jupiter's rings. After completing its primary mission, Voyager 1 headed towards the Kuiper Belt and the heliosphere, areas that help scientists understand the universe. One of its most famous images is the pale blue dot, a photo of Earth from over 4 billion miles away, highlighting the fragility and preciousness of our planet. Additionally, Voyager 1 carries a golden record containing sounds and images meant to represent life on Earth to any potential extraterrestrial civilizations. The probe continues its journey, now in interstellar space, providing valuable data and carrying a message from humanity to the stars. Voyager 1 has traveled quite a distance and is currently 154 astronomical units away from us, approximately 14.2 billion miles. This makes it the most remote human-made object, a title that originally belonged to the Pioneer 10 mission until Voyager 1 overtook it in 1998. Voyager 1 is way beyond its best-by date, having even surpassed its twin, Voyager 2, which was launched 2 weeks earlier. Voyager 1 moves at a speed of 9.7 meters per second, or 35,000 miles per hour, a speed unimaginable compared to the fastest sports car, which only travels at 305 miles per hour. Currently, Voyager 1 is heading toward the Oort cloud, a hypothetical layer of icy objects surrounding the solar system. Although its existence hasn't been confirmed, astronomers are confident it's there, much like the once theoretical black holes. Unfortunately, Voyager 1 won't return to the solar system. It will keep in touch with Earth until at least 2025, but eventually, we will lose contact with it. In 300 years, it will reach the Oort cloud, and in 30,000 years, it will leave the solar system. If it remains intact, Voyager 1 will approach the red dwarf star Gliese 45 in the Giraffe constellation in about 40,000 years and continue wandering the Milky Way galaxy. In May 2022, NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported that Voyager 1 began sending strange data to Earth. Despite functioning normally and executing commands from Earth, the probe's Attitude and Articulation Control Subsystem, AACS, readings don't reflect its actual orientation in space. This system supports the probe's orientation and helps it maintain contact with Earth. However, the antenna signal source remains correctly positioned relative to Earth, and the problem hasn't triggered any onboard onboard fault protection systems, nor has the probe entered safe mode. Susan Dodd, the head of the project, acknowledges that while the issue is mysterious, it's not entirely unexpected given Voyager 1's 45-year journey into interstellar space, where high radiation levels are unprecedented for any spacecraft. NASA scientists will continue to monitor the data from Voyager 1 to understand and potentially fix the problem. If they cannot, the team will adapt to the new conditions. Communication delays of about 20 hours and 33 minutes complicate troubleshooting. Meanwhile, Voyager 2, although also in interstellar space, 12 billion miles from Earth, is functioning well. We can only hope the issue with Voyager 1 is resolved and speculate on how much longer it will last, whether it can reach the Oort cloud in 300 years, and continue